Hello everyone, this is Akshita, your educator, and I welcome you all on the platform of Global Online. As we know, friends, Global Online platform has launched a complete course for upcoming CTET examination 2023. And in this particular course, we'll be discussing the whole syllabus of the CTET exam. With this particular series, we have startup with mathematics paper 1 and paper 2. So in upcoming lectures, we'll discuss all the syllabus of mathematics paper 1 as well as paper 2. In today's lecture, we'll be talking about the mensurations, like how to calculate the question based upon the 3D structures, questions on cube, cuboid and cylinder. Even the weak students who find themselves weak at mathematics can score maximum marks in the examination, and the confirmed target of 30 out of 30 will be the highlighting feature of this particular course. Central Teacher Eligibility Test for that complete course has been launched by Global Online platform for paper 1 as well as for the paper 2. If you want to get enrolled to the particular course of CTET paper 1 as well as paper 2, you can download the Global Online application from the Play Store and can get enrolled to the course, or you can simply contact us on this given WhatsApp number, which is 8669316919 or 8179138413. One-on-one mentorship will be provided, and this is the highlighting feature of this particular course. Excluding this, as I have told you, by Global Online application also you can get enrolled to the course. So install the application from the Play Store with such a logo. Open the application, you will find such type of interface where there is an icon named as a store. You have to click on it. You'll move to the page called as My Courses, where there is a search tab. In that search tab you have to type CTET. So when you type CTET, the CTET paper 1 as well as paper 2 course will be displayed downwards, and hence you can get enrolled to the course. Without any further ado, let us begin with the lecture. Now, before starting the lecture, these are the questions based upon the 3D structure. So basically the cube structure will be analyzed maximum today. The questions based upon the cube will be maximum over here. Okay, so the first question: if the diagonal of a cube is of length L, then the total surface area of the cube is what? This is the question. Okay, now we know the structure of cube. The structure of cube is in such a way that each face of the cube is a square shaped. Please note it, that each face of the cube is in square shape. Each face of the cube is in square shape. So you can highlight this point by writing it as: there are total 6 faces in a cube. There are total 6 faces in the cube, and all the faces are square in shape. Okay. Second thing, out of these 6 faces, 4 faces are the lateral faces. These are the lateral faces, and now we know what are the lateral faces. Basically, face excluding the top face and the bottom face. We have to exclude this face and this face. Remaining all the faces surrounding this particular structure is nothing but the lateral faces, and the top and bottom face are total 2 faces. One is the top face and the other one is bottom face. Hence these are the 2 faces plus these 4 faces, lateral faces, gives us 6 faces, and each face is square in shape regarding the cube. Okay. And second thing that you have to keep in mind here is there are total 8 vertex. There are total 8 vertex. 1, 2, 3, 4, 5, 6, 7 and 8. Total 8 vertex and 12 edges. Now what is edge? What are the edges of a cube? The line I am drawing here, this particular lines, these are nothing but these are the edges. These are nothing but these are edges. So such edges, there are 12 total edges. Okay, got it? So these are the 3 important points that you have to remember regarding a cube, that in cube each face is square in shape. There are total 6 faces, out of which 4 are lateral faces and 2 are the top and the bottom face. Okay, there are total 8 vertices and the 12 edges. Second thing that you have to keep in mind now is the formula for the diagonal. Okay, I'll explain it to you in the next slide. Just let me rub it out. For example, the same cube. I may not be able to draw proper shape, but try to understand that what I have to explain here. For example, we have a diagonal, and this is that diagonal that we have placed in a cube. Okay, to to find out the value of a diagonal is equal to under root of 3a. And what is a? A is the side of cube. Okay, so diagonal is equals to under root of 3 into side of a cube. This is the diagonal of a cube. Okay, so based on this formula we can find the answer of the given question. Now diagonal's length in the given question is L. So L is equal to under root of 3a. Can I write like this? Yes. So can I write side of a cube, that is a, is equal to under root of 3 divided by L. So I have got the value of side now. So I have to find the total surface area of a cube. I have to find the total surface area of the cube. So the total surface area of the cube, the formula for that is 6a square. How come? I'll explain you now this. Okay, before that we'll solve this question's answer, and then I'll tell you two formulas, that is lateral surface area, and the second one is the total surface area. Okay, so here total surface area is equals to 6a square. We have got the value of a, that is equal to under root of 3 divided by L. So I'll take this as 6 into under root of 3 divided by L raised to 2. So I'll get the answer as, sorry, something went wrong. Here comes L by root 3, not root 3 upon L. Okay, here also we have to rub this out. There was a mistake where I made it like it was L upon under root of 3. So I'll get the value of a square as L square upon under root of 3 square. So tell me, what is under root of 3 into under root of 3? Under root of 3 into under root of 3 gives us 3. So this will give me 6L square upon 3, that is 2L square. So the value of the total surface area of a cube is 2L square. Got it? Yes? Okay, so now we have understood two formulas over here, that is the diagonal of cube, which is equal to under root of 3a, total surface area is equals to 6a square. So let us check few formulas for the cube. When they ask you regarding any, if they have given you any cube structure and they are asking us okay, hold on. Now this is the cube structure. Okay, this is the structure of a cube. So in this structure of cube, we have right now studied the diagonal of the cube can be written as under root of 3 into a. And what does a represent? A is the side of the cube. The second thing that you have to keep in mind here is the lateral surface area. Two formulas, one is the lateral surface area and the second one, that was total surface area. Right now I have explained you excluding two faces. Please try to understand. We have to eliminate the two faces. Which two faces? Top face of the cube. For example, this is the top face and this one is the bottom face. After removing out these two, whatever the faces are left, that face's surface area gives us lateral surface area. Please try to understand. There are total 6 faces as we know, but there are only 4 lateral faces. This is the first lateral face, this is the second, back side is the third, and this one is the fourth. There are total 4 lateral surface, and the area of this gives us lateral surface area. Hence 4a square is the correct answer. 4a square. So 4a square, because all of the sides of the cube are square in shape, so hence we have taken 4a square. Second thing, if I want to take the total surface area. Total surface area means what? The lateral surface area plus 2a square. Why 2a square? Because I'm including here two faces. One is the top face and the other one is the bottom face. So here total surface area will give me lateral surface area 4a square plus the total surface, the top and the bottom surface area is 2a square. This will give me 6a square. Hence the total surface area is equals to 6a square. Got it? Two formulas. One is a diagonal formula and the another one is the formula for the total and the lateral surface area. The second formula that is important is the volume. Volume of the cube is equals to a cube. Volume of the cube is equals to a cube. Yes, this is a simple formula. Everyone must be knowing this. If not, then please keep in mind that the volume of cube is equal to a cube. Diagonal is equal to under root of 3a. Total surface area and the formula for the lateral surface area, that is 4a square and the 6a square. Moving on to the next question now. The volume of the cube is given, that is equals to 5832 centimeter cube. What is the total surface area is the question that they have asked us now. Now we know that what is the volume of the cube. Volume of cube is equal to a cube. A cube is what? Volume of a cube. So what they have given is volume that they have given here, that is 5832 centimeter cube is equal to a cube. Can I write like this? Yes. So this is the cube root of 5832 is a cube of, it is a cube of 18. It is a cube of 18. So a cube is equal to 18 cube. So can I write a is equal to 18? I'll get the answer as a is equal to 18, that is the side. Now we have got the side. Now we can find the total surface area. We know the formula for the total surface area, which right now we have discussed. That is 4a square plus 2a square. That will give me 6a square. We know the side now, 6 into 18 square. 18 into 18 I'll do here. So what is the square of 18? 324. Yes, am I right? Yes, 324. And this will give me 6 4s are 24. 4 and 19. So 1944 centimeters square is the total surface area of the given cube. Again, based upon two formulas we have solved this question. One is volume of a cube is equal to a cube, from which we have find out the side of the cube, and the second one is the total surface area, which is giving us 6a square. Got it? So the correct answer is 1944 centimeters square. Moving on to the next question. A cube of maximum possible sizes is cut from a hemisphere of radius square root of 6. This is radius square root of 6. Okay, please note it as a square root of 6 centimeter. One identical cube is placed next to this cube to form a cuboid. Find the total surface area of the cuboid, they have asked us. Okay, so to understand this particular question, first thing that you have to understand here is that just a minute. Okay, so what they have given here, a cube of maximum possible size is cut from a hemisphere of radius. Okay, so to understand this particular question, you can use directly one formula. Which one formula? First we'll explain the formula, then we'll come to the question. For example, we have a cube. Okay, this is a cube, and this particular cube we have actually enclosed in a hemisphere. Exact size. This is the maximum size possible of a cube which has been enclosed in a hemisphere. This is the half side of the sphere, that is hemisphere. The cube has been possibly adjusted in this hemisphere, for example. Now this was a hemisphere from which we have made this cube. Okay, there was one hemisphere, we have cut down this hemisphere and formed it, or we have given the shape of cube to it. Okay, so in this particular situation, if the radius of the hemisphere from which we have made the cube is given to us, for example, the radius of the hemisphere is r. Okay, try to understand the condition that there was one hemisphere, and cutting down the hemisphere we have formed a cube of maximum size, means larger size, possible utna larger size, and the radius of the hemisphere has been mentioned, which is equals to r. So in this condition, the side of the cube is given by a is equal to under root of 2 divided by 3r. This is a formula. Please keep in mind that whenever we are getting a shape out of a hemisphere, getting a shape of a cube out of a hemisphere of maximum possible size. So here the side of the cube can be given as a is equal to under root of 2 divided by 3r. What is a? A is the side of the cube and r is the radius of the hemisphere. Now using this particular formula we are going to solve this question. Okay, what they have given, a cube of maximum size possibly is cut from a hemisphere that we have cut of a radius. Radius is mentioned, radius is equal to under root of a 6 centimeter. One identical cube is, now this is the first question, this is the first part of the question. Okay, we'll find the side of the cube first. A is equal to under root of 2 divided by 3 into under root of 6. Got it? So here A will become under root of 2 into under root of 3 into under root of 6. So this will give me under root of 2. So under root of 2 into under root of 2 will give me 2 centimeter. So we got the side is equals to 2 centimeter. Now what they have given in the second part of the question is, one identical cube is placed next to this cube to form a cuboid. That, for example, this was the cube that we have placed in a hemisphere, that we have obtained from a hemisphere. This was the cube, for example, I have drawn here, and exactly a cube of same side has been placed next to it. So this is forming now a shape of cuboid. This is forming a shape of cuboid. We have placed another cube of same size next to it, so it is forming a cuboid now. The shape of cube has turned into cuboid. So now they are asking us to find the total surface area in centimeter square of a cuboid. We got the side. Now we have to find the total surface area of the cuboid. To find the total surface area of the cuboid, there is a formula. Formula is twice of LB plus BH plus LH. So this will give me 2 into, what is the value of length? Length will give us 4 centimeter. How come 4 centimeter? Look, the side of this cube was 2 centimeter, 2 centimeter, 2 centimeter and 2 centimeter. Such identical cube has been placed next to it now. Now this was 2 centimeter, this is 2 centimeter. So this will give me total 4 centimeter. So length has converted into 4 centimeter. Breadth has remained the same. Breadth is the same. 2 centimeter only. 2 centimeter only. But the length and the height has changed now. The height is again 4 centimeter. So plus 2. Again breadth is 2 into height is 4. Sorry, height is 2, not 4. Sorry, height is 2 only. Okay, so length has converted into 4 and height again into 2. So this will give me 2 into 8 plus 4 plus 8. The value finally obtained is 40. So 40 centimeters square is the total surface area of the cuboid. Correct answer to the given question. So in this particular question we have actually obtained the value of the side of a cube first, and based upon that we have find the total surface area. When two same cubes have been connected to each other, the thing that you have to remember here is, whenever the two cubes of the same size are connected to each other, they form the shape of cuboid. Got it? So in today's lecture this was only the questions that we have discussed. Okay, in the second part of this particular lecture we'll discuss the next remaining questions. Okay, so this was enough today's lecture. Thank you for watching it. I hope you are liking the video and the content. If you are liking it, please hit the like button and let me know in the comment section, and please do subscribe the channel if you are new to it. Thank you for watching my video. Have a great day everyone. Bye.